Okay, so hello everyone, and welcome to the first set of sessions at JParn 2025. I'm very happy to welcome on stage Tihomir Mateev from Redis. He'll give a very interesting talk about the client side of the things. So, Tihomir, I'll give you the word. So,
thank you very much, and thank you for coming. My name is Tihomir Mateev. Some of you already know me. I've worked a couple of almost 15 years in VMware, and after that I joined Redis and worked on the drivers client systems team. I have primarily worked with clients the last couple of years, I would say, but I have an overall idea about the distributed applications and the web stack as part of the job that I'm doing. And today I'm going to try and entertain you on that topic as much as I can. I have to be honest with you. When I first started thinking about this talk, I tried to use the latest tooling, and you know the latest tooling is AI. So I tried to ask AI to write me a presentation because I'm a lazy programmer, and this is how we do stuff. And while it was actually outputting all the suggestions about the structure of the talk, about the topics, about different things I should mention, I realized that just about anybody can do that. And there would not be a lot of value for you to come here and just listen to what ChatGPT told me yesterday. So instead, what I did is I tried to compile a set of stories where I can talk about different stuff that I've run into during my career, and probably help you learn some lessons that I myself learned. But because it would not be honest to skip a lot of the information about client-side, client-server communication and client-side development, I have a bonus track, which is in the beginning of the session, which is basically telling you everything you should know about client-side, client-server communication and what you would otherwise learn from ChatGPT. So the bonus track is basically the time where those of you who are more advanced may drink their coffee and have a rest before the actual action. And I will try to make it in 2 minutes. I drank my coffee, so it's possible. I've tried it, but it's going to be a lightning talk, a slide about a lightning talk. So, what is client-server communication all about? Obviously, you have a server. I started with the server because you have there all the basic business logic of an application. It's only fair for it to be a central place in our presentation. But the server itself is just providing you the options to consume a certain set of features. Several different entities could consume the same set of features, but that's not really enough for you to have an application. So you have a client that's actually consuming them. One or more clients are working with this server, consuming the features that the server is providing. Now, typically, the client and the server are not in the same process, so they have to communicate with some sort of remote method invocation mechanism. In today's world, where more and more applications are in the cloud, and we have these distributed applications working everywhere, Facebook, LinkedIn, all these applications actually have a huge layer of networking between the client and the server, where there's gateways, load balancers, security appliances, all of them working in some way to help you shape and route the traffic to achieve some sort of scalability, some sort of availability, and stuff like this. So there's a lot of things between the client and the server today. But if you think about it, and if you see this picture, it's obvious that the components within this picture beside the client, which is the appliance, the gateway, the server, they're all actually clients because they talk to each other. Whenever a server initiates a connection to another server, it's actually a client. That's what it does. So clients come in all sorts and shapes, and you could see very simple examples like the web browser. A web browser is actually a client of different types of applications which are loaded there, and it connects to the server to finish his job. But you have also native clients, such as all the applications in your GSM, like in your mobile,
Most of them are clients because they contact some remote service. You have IoT, like your fridge. Your fridge, if it's IoT, it connects to a server, and when it sees that you've run out of X in orders in Amazon X, it basically is acting as a client. You also have edge, like in cars, in machines, in factories. All these things are clients. And of course, I mentioned already that servers are also clients. So any device connected to the internet would eventually end up being a client at some point. What the client does, it connects to the server, initiates the whole flow, usually does some authentication, not always, depending on the protocol, depending on the server, it could be assigned a session. These all are optional, but frequent components in the communication with the client. Then I mentioned protocols. There's a lot of different protocols, and this is like the topic of several different talks that you could have on this, so there's no easy way to condense it for me. Basically, depending on what you want to achieve, depending on what you are doing in your application, different types of protocols could be working for you. The responsibilities of the client: it needs to collect user input with all the caveats around it. It needs to display data in the best way because it receives it in some raw way. It has to display it in a way that's easier for the user. If this is a client which is a UI, you could also have API clients which synthesize the data in a specific object that's easier to handle for the client application. They also do a very important thing, which is handling the network. That is replies, network jitter, all the things that would happen during the communication with the remote server. It is responsible for them. Now, when I say UX, don't always think about UI. Any sort of interface, whether that's an API, whether that's a service, whether that's a terminal, they all have user experience. The user that consumes them needs to have the right user experience for them to work. I just did that. I'm not sure what happens. And of course, you have to choose the right type of clients. There are different types of clients. Usually, in most cases, the best type of client is a thin client, which is that's because if you want to spread, if you want to have different clients contacting the same service, you don't want to implement the same kind of logic in all the clients. You want to keep it. You want to keep it in the servers, in the business logic, and at the same time, the client should be thin. And not least, last but not least, it has to be secure, a client. Do you think there's something we can do about this? I'm not sure it's the screensaver because this is on. It may be that the connection is... Thank you. But about security, very quickly, it's very important because the clients are usually in a public network, on a public device, or your personal device, so they need to be very secure there. The easiest way to hack a system is through the client application itself. And we get to the stories. I did not manage to do it very quick. Sorry about that. It should have been a lightning talk. It became a talk inside the talk. But the stories are the fun part, I guess, at least to me. And I want to talk about a few things that I run into while I was working on in the different companies that I worked at. One of the things is, and this slide is very easily confused, so I'm going to try and put it in a very specific example so that you know what I'm talking about. Often, if you've worked developing a client, you should have been running into this issue, and that's probably the worst issue that I've run as a developer, when everybody just expects your part of the code to do all of the job. It's a distributed application. There's a lot of different components. There's servers, there's middleware, there's also other clients, and suddenly the people that see your application, they see the client because that's how they consume it. They consume it through the client, and they assume everything needs to be in the client because it seems logical. It's where you would put it because that's what you see. But of course, there's a lot of things underneath. And now imagine Facebook. Facebook has several different clients. Like you have a web client, you have an Android client, you have an iOS client, As far as I know, they're native, so they're different code, really. So everything that you implement in a client, in a single client, you have to implement in all the clients. And of course, if it's a UI feature, you have no choice, because it's basically what you have to do. But, well, there's another slide that actually talks about this, so I'm not really truthful, but we'll get to that. What you have to do is, and that's just a message from all the times that I run into this problem, I usually ask myself 3 simple questions, or at least a couple of simple questions, but these are the ones that pop up in my head always. So the first one I already explained about: do other clients have to implement it, and can they avoid implementing it? If they could, then this is a business logic that you could put in the back end. Would it affect performance? Clients are usually run in a different machine. They're not in a server. Like if this is your phone, the hardware there, the network bandwidth that you have, they're much more restricted than the things on the back end in your server. So normally you would not want to do things in the client. And of course, there's the question about orchestration. Like if you have a complex system that does a couple of different steps, one after the other, the client is not the best place to orchestrate, especially if it's like a thin client in like a mobile device. Imagine you're driving in a train and you're booking your flight, and your client in your mobile device is actually orchestrating. So it's going to one service, it's booking the first flight, it got the ID, now it's booking the second flight, and you go in a tunnel. And in the tunnel, you lose your connectivity. If the client was orchestrating all this, you leave the system in an invalid state. You don't know where it stopped. You can't, in some ways, resume it. You may not be able to resume it in many hours. So you don't want to do orchestration on the client, except in certain specific cases. So that's one story. But in the same time, there are situations where you would want to switch roles, like you would want the client to work more like a server and the server to work more like a client, again, depending on the actual requirements to your system. I'm going to give you 3 simple examples. There's a lot more, of course. These are the ones that I came up with after thinking a bit. The first one is something we were doing in Redis recently. We added to our drivers, the Redis drivers, we added client-side caching. This is a feature that allows you to cache some of the data that you would otherwise query the Redis database with and not hit the Redis database. It seems funky at first, because what Redis often does is be a cache. So why would you be doing the same thing that Redis is doing? Well, obviously, those of you that know more about caching and have experience would quickly see that the good rule about the cache is it's as efficient, as close it is to where the computation happens. So you're basically doing a level 3 cache in your driver, and then you have a level 4 cache in your database. But essentially, your driver is doing what your server is doing, just to a smaller scale, of course. Another similar example, but all the way around, is how server could do the client work. In server-side rendering, when you have a huge system, multi-services system, a multi-services system that has micro front ends, microservices with micro front ends, you may end up having to build the UI dynamically from the different services behind the scene. If you do it on the client, you have the same problems that I just mentioned about bandwidth, about computational power, and you may end up slowing down the UI. What you could do in this specific case is you could actually have a component on the server side that renders the whole UI for you before that, and just gives you the result, which would greatly speed up the building up of the UI. And of course, I mentioned client orchestration, and I said that it's bad, and I gave an example, but there's an example how, in some cases, you could actually want to do this. We had at VMware such example where we wanted the client to participate in the data path, because if we were to put a component to aggregate all the different requests that the client has to do and spread them around in all the servers, which is a better, generally speaking, a better architectural approach. we would have had a bottleneck there. So we wanted to avoid this bottleneck, and instead we asked the client to orchestrate the upload of the pieces of the files to all the different servers, you know, having to pay the price that it may sometimes end up in a not very valid state, but there were ways to clean the state also. But this is an example of where you break the rule for some other reasons which are also valid. Now, about how fast your server is, and this is very important. This is my favorite slide because nobody understands it. So I'm going to test you. I have a candy, actually. The first one who says it understands, after I finish, I'm going to give the candy to you. So the moral of the story is, obviously, if you have a fast server, it doesn't really matter in the same time if you have a very slow client, because you don't see the speed in any way. The client is slowing you down. What I did is I used AI again, because, you know, AI. And I asked it to just go there and make a comparison of all the most popular, most popular drivers for Java, for Redis. And I give it a huge prompt. And it ended up with something that looked nice. I don't know. Because it's AI, it's obviously not a hallucination. It's right. So we may be very trustful of this data. But what I did is I opened up the project it generated in order to come up with this data, and I just changed a small, well, not small, but part of the configuration of the driver that I'm maintaining, which is the lattice driver. And you can see that it had a bit of an improvement, like 10 times, which I would say is good. And the moral of the story, I think I'm going to tell it to you so the candy is for me. The moral of the story is we don't want to consume things as the AI gives it to us, or a Stack Overflow gives it to us, or like any type of forum gives it to us. We want to know what we are using, because otherwise we would not actually benefit from the speed of the system. I guess the LLM that I used was not really very well trained about how to optimize lattice driver for get and set operations, which I find interesting. But, this is the moral of the story. And then, this is more of a cautionary tale. And this is not extremely client-related, but I think that people that work on the client side or with the client side might run into it a lot of times. Because we often, when we go to any type of organization, a larger organization, because I'm not talking about small startups where it's 5 people and everybody is touching everybody's code and there's no boundaries there, so this totally does not concern them. But in larger organizations, there are these organizational boundaries that we're instinctively following because of our herd instincts. We want not to get into other people's work. And like if you work in the UI, you would like to focus on the UI, and you don't want to know what happens in the backend. And if you work on like the APIs, you do your APIs, you follow the best practices, the requirements of the organization, follow the security model and stuff like this. And sometimes we end up using things that we totally don't understand, like a black box. And this is actually bad. And this is really bad because the clients, they don't care about these boundaries. Customers, in terms of clients. I'm sorry, clients and customers is sometimes intermingled in my head. But the customers, they don't care about these boundaries. They want to use the application in the best way, with the best performance. And the fact that you did not open up and read somebody's code, they don't care about this. They want you to use it the best way. And this is how you should use it, by the way. There's no reason for you not to read other people's code. We have to be sure, because like basically these arrows here are just for example, but you can't do integrations, can't do extensibility without knowing how integrations are done. You can't do ecosystems without knowing how APIs are done. You can't do UI server communication without knowing how the server works. And it's both ways, by the way. If you work on the server, you kind of have to know how the UI works. It may sound irrational to you, but this is how it's consumed. So your job is not done the moment that you implement the feature and provide the API for it. You have to know that the user is consuming it properly, and you have to go to the UI folks and say, that's a good way to use my code, but that's not the best one. There is a better one. I've envisioned it in a different way. And it's totally normal. So don't be afraid to overstep these boundaries. They're imaginary, they're artificial. They're not there. And when we said APIs, these are some very crude, quick examples that I found out in GitHub. On top right, you can see how many times in GitHub people have basically abused APIs, because what they do is they use reflection to change the visibility of a field. And of course, if this is a unit test, I don't care. Nobody cares. But a lot of these are not unit tests. So what people do is, I don't like your API. I think I need to consume this method, although you've specifically spent the time to hide it. And it's a cautionary tale. There's two things to learn here. The first one is nobody is really forced to use your API as it is. They can use it whatever way they want. The second one is if you find such a case, then basically you have failed. You have not provided to the person that's consuming you the best way to consume you. Either it's missing documentation, which would explain how to do it without reflection. Either it's the functionality is missing, but something is missing there, and this is why they did it. Don't always assume people are hostile. They don't want to do it just to mock you. It's just that they wanted to do it for some of their requirements, and they had no other way. And the other thing is, on the bottom right, you see how many hundreds of issues are marked as invalid. Invalid means somebody has been using the lattice driver in a way that it's not supposed to be used. Fair, and I usually would go and say, I'm sorry, you're not using the driver in the right way, close the issue, forget about it. But that's not the right way. You have to think about why they used it. Was it not very obvious how to use it? Was it that it was missing some functionality? Sometimes users are lazy. And in that case, you can't help them. You can't go and make them use it the best way. But if you can improve the documentation, if you can improve the API in some way, this is actually a pointer. Somebody went to your tracker and said, I was not able to use that. And you have to use this opportunity to improve your code. These are the 4 things that I mentioned just conversationally. And the last one, the standardize, I'm not saying about always using standards, but we have to make sure that our code is as, and also UIs, of course. All of the things that I say relate both APIs, user interfaces, everything that you could provide as a interface. They need to be in line with other similar APIs. That helps the user quickly adapt them, and overall, the user experience improves by doing this. And this is a controversial slide. First of all, a disclaimer, I was told that Spotify no longer uses this approach, exactly the same approach, but this is how it used to be a couple of years back when they created this YouTube video. You can scan the QR if you're interested. They spend some time explaining their process and stuff like that, but that doesn't matter. Assume this story about Spotify as an old one and not very latest, but it's used as an example of what I'm going to say. So when you do clients, there is a very sugary thing that you can end up doing, which is, I want to quickly solve the problem for all platforms. I don't want to write code for Android. I don't want to write different code for iOS than for web. I want to solve it for everybody. And this is where progressive web applications come. They promise you this situation where you do the code just once, and it's actually somehow modified or compiled, or depending on the technology, of course, because there's different hybrid technologies. You end up having one code for different platforms. And it's a good promise. It's a good promise, but it comes with a couple of trade-offs that you have to know about. I've personally worked on the bottom left part, which is the the mobile client for the vSphere suite. And the reason we initially chose to do this is we wanted to have exactly the same user experience in the mobile client as in the web client and everywhere. Basically, we wanted to have the same user experience because everything that is different in experience requires somebody to train the customers how to use it, or ends up being tickets in the end. They ask us how to do this, how to do that. So we wanted to solve this problem. We did a Cordoba-based application. Cordoba is a framework that gets your web application and creates outputs from it, different mobile applications, and you have the browser embedded in the application that renders this application. Something very similar was done with Spotify. They used iframes there, but basically the same. And now I think they're using React Native, which is a different type of hybrid technology that allows you to do the same thing. And yeah, so if we go back to the mobile client, where I can talk in length for many days, it did some of the things. So these are successful stories on the left, I would say, because we had a huge adaptation, a very rapid development process there. But it came with trade-offs, and you have to know that if you make this choice or if you participate in something similar, maintenance is definitely much harder, and debuggability, especially debuggability. Now, of course, it depends on the framework, depends on the platforms, depends on the process, but you can never test it easier when you have more components throughout the whole process. Like in our case, if we ended up with a ticket that in Android version, let's say, I don't know, 12, some version, and phone, whatever version, there's something as of a problem, what you'd have to do is you'd have to have the hardware, because that's the only way to reproduce it specifically there, if it's not shown somewhere else. So you have to have the hardware, you have to connect it to your computer, you have to enable debug mode, you have to have a browser there. Sorry, you have to have a setup on your developer machine that allows connection to the Android device if we're working with Android. I'm not even going to mention iOS, which is much harder. I'm saying the happy path here. So you basically have to have several different components configured just to get to the point where you put a breakpoint somewhere and see what's happening. And it's really much, much harder. In the world of Redis, there's drivers that try to do the same thing, supported by our competitors. And I've personally had some experience with one of them. It just threw an error. And the error was, I can't continue. And because it's a hybrid driver, it basically has on top of it, let's say, Java or some other framework. And below that, there's a native part, which is compiled from Rust. And you have some way of communicating between them, which is the middleware. And that's all in the driver. So when you want to debug it, it's not that easy. These are really huge problems. Of course, I'm not saying they don't work. I'm saying there's a price to pay. Performance, nobody can convince me that the performance could be the same when you have an additional step. Like in the case of this driver that I'm speaking about, the data that you receive in Java had to go through a protobuf, so it's converted to data that the underlying Rust code could use, and then sent over the wire, again converted to bytes, because that's what most drivers do. So you have two steps instead of one step, usually how drivers work. And of course, funky UX in the case where you have a hybrid UI and partial code reuse, because if they're promising you're going to do code reuse, it's never the same. I mean, there's always, you have to put an if statement somewhere. You could not reuse the same UI for desktop and for mobile, for instance. I have an example here for disk control. You would want it to render differently. Just you don't have the space. And in the same time, if you render it on a desktop, you don't want to waste all the space. So there's always an if statement. So yeah, a bit controversial. And this is another cautionary tale from the time when I was in VMware. There was an application, I briefly mentioned that in the start of the talk, where the client had to orchestrate the upload of a file. However, the initial implementation of this solution was involving a separate component. Of course, there were some reasons to do that when they did it. First of all, browser back then allowed you to do plugins, which now is impossible today. But before, there was the option to do a plugin, and what you would do with this plugin is you have much more streamlined access to the system. And this allowed them to have a simpler JavaScript in the application, then start the flow of the uploading of the file from the plugin, and a lot of the actual file upload stuff, the breakdown of the file, stuff like this, all of it is done in the plugin. However, it meant that you have two components. And with the browser, that's three components. So what happens is our clients would get version 5 of our application. They will install the plugin from version 5, which is plugin version 5, and they will use it in browser, Chrome, whatever, 100, for instance. And then tomorrow we release a new version of the app, and we have a totally different compatibility matrix then. We have a new app with an old plugin, because they would not install the new plugin because they already have this old plugin, and a browser that may or may not be new. So the compatibility matrix was just, I don't even want to remember these times. You don't want this happening. You don't want to have so many components you have to deal with. The simpler, the better. What we did is we removed entirely the plugin. Well, to be honest, partially because they stopped supporting plugins and we had to at some point either way. But we removed the plugin, we moved to the new browser APIs that allow you native file transfers. And what we ended up with was a much simpler implementation that also allows us to use all the native browser capabilities and not rely on different components. Very simple, very fast. And I was quicker than I expected. This tale is actually very quick, and we'll have some time for Q&A. When I got to Redis and I was hired there, the manager that hired me said, "Okay, you'll be the next maintainer of this Java driver. Please go over these recordings where the previous maintainer is going through all the things that you should know." And the team was asking the maintainer this and that. And at some point, the maintainer actually asked them, "Okay, what do you think is the biggest problem the driver has? You've been there, you went to the tracker, you saw the issues, you've read everything. What do you think it is?" And our colleagues, they assumed it's some of the most common things that you would run into the tracker, like there was a problem with some clustering stuff, there were some connectivity retry issues and stuff like this. So they mentioned all of them, and he was like, okay. And then he came and said, I know there is a problem with the driver in the way that it handles data, because sometimes you get these, the responses come in a wrong order, and you don't deserialize the data, the right data to the right request. And it's a huge problem. By the way, just a couple of months later, there was a story that a client that was using this driver ran into this, and what happened is you would, one broker of stocks would send a request, and because the server would run out of memory in that specific moment, another broker would receive the response for this same request. So it's a huge issue. But what the maintainer, Mark, said was, this is the biggest problem. The biggest problems are issues that you know are there, but you can't reproduce and you don't know what the problem is. And there are a couple of these. Why I'm saying this and why it's related to clients because the easiest issues are the ones that you can reproduce. I would say I have my Friday mornings are dedicated just to prune them, because if you have reproducibility, it's an issue that you can fix in 2 to 4 hours. The biggest issues that I never have time for are these that don't have reproducibility at all, or not easy one. And it's good to plan for them if you could, but they often just live in your tracker for a long time until somebody manages to help you with the reproducing the issue. And yeah, I was faster, not because of my lightning talk. I'm open to questions if you have any. About everything, the world. I can talk also about melting. Yes?
Okay, thank you. How do you tackle problems that you know exist but cannot reproduce? Because I recently had a similar problem, and it took me quite a while to actually solve it.
Yeah, that's the million-dollar question, I would say. I don't have a good answer for it. In a healthy community, which I believe the driver that I maintain has, and it's an open source project, so it doesn't apply to closed source projects or corporate projects that have smaller communities or contributors there. But in this case, helping the community with pointers, how to reproduce it, how to create a scenario to reproduce it, where to go, in what direction to go to test it, would greatly increase the chance. But to be honest, it's very hard. It's very hard. And it's really annoying to me as a person, because I've seen countless times where people would come to, like, they see an exception that's very specific, and they see it once a week in their log files. And it's like, I know it's a problem, I see it there, but I can't wait for a week with the debugger attached just to get to this endpoint. And there's no easy answer. Of course, typical things that you would do with debugging. You would put tracing, you would put some sort of telemetry if that's required, like if it's depending on the issue. You would try to see signs of the state of the system at that particular moment. Was it running out of memory? Was it running out of space? Are there related issues? By the way, we often neglect to look at like in this specific case that I explained, the driver was running out of memory, and that caused the problem. But the problem was like 2 minutes or sometime after the out of memory error. So you would get at some point an exception that says, I can't map this data to this request, which indicates that there's a problem in the order, but you would get it much after the out of memory. And in this case, you just had to scroll back up several seconds or minutes to see that there was something happening before that. Again, hard question with many answers. Something else? I can also talk about mountain biking and occasionally running. I'm a very slow runner, so I can talk about this a lot, slowly. Well, there was promise of beer, so I think we can close. Thank you very much.